أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي ربي زدني علما وارزقني فهما. Oh Allah, increase me in knowledge and true understanding. Amin. Assalamualaikum warahmatullahi wabarakatuh. I am Ida Murni Jamari from YMS EduTech Learning Hub. Inshallah, we help students to improve in math and science by 2 grades in less than 3 months. So Alhamdulillah, today is our second chemistry Facebook live streaming. And this Facebook live streaming is suitable for secondary 3 as well as GCEO and N-level students of 2018. So for those of you who are watching right now or who will be watching later, please share this video so that more people can benefit from it. And inshallah, through sharing something beneficial, Allah subhanahu wa ta'ala will reward us accordingly, inshallah. Okay, so what will I cover today? Just a recap of what we did last week. Last week, I touched on naming chemical compounds, especially ionic compounds, as well as compounds that involve polyatomic ions. So if you have missed out on that episode, that's alright. Simply subscribe to our YouTube channel. I've already provided the link to accompany this Facebook live streaming. You can just click on the link and then subscribe to our channel to watch our first November special holiday chemistry video, which was on naming of chemical compounds. Alright, and there are other videos over there at our YouTube channel where we have, apart from chemistry, we also have E-Math for O-level and N-level students, as well as PSLE Math and PSLE Science videos as well. So do check out our YouTube channel, subscribe to it, watch it, and then share it with those people who may benefit from it, inshallah. Okay, so today, what am I going to touch on will be chemical formula. Just like naming of chemical compounds, this is my second video this year touching on chemical formula. So like I mentioned last week, what I'm just covering in November is just the basic, the foundation, because for the whole of November I will be touching on, last week we did chemical naming, today we're doing on chemical formula. Next week I will be sharing with you how to write balanced chemical equation, and on the last lesson together during this Facebook live streaming, I will be sharing with you how to write ionic equation, balanced ionic equation. So these four are the basic of chemistry that you must know, and these four concepts are important for many topics such as acid, bases and salts, speed of reaction, mole concept especially, as well as chemical bonding. Okay, so it's important that it is important that you get yourself clear with these four concepts that I'm going to share with you throughout November, inshallah. Okay, so without further ado, let us take a look at how to write chemical formula. Now, chemical formula is heavily dependent on one simple thing, that is valency. What is valency? Valency is the number of electrons involved in bonding. Okay, so you will see that later for all the 3 types that I'm going to touch on related to chemical formula, all of them involve valencies. Okay, so let's look at type 1. Type 1 is related to group number. Okay, we are going to relate group number to valency. And how do we do that? Okay, so type 1, if let's say I have, okay, type 1 valency, I'm going to write valency here so you can see. Okay, valency, group number. So what are the various group numbers we have on our periodic table? We have group 1, 2, 3, 4, 5. Okay, I'm not going to touch on 4 because 4 is special. I'm going to skip 4. I'm going straight to 5. 5, 6, 7. Okay, and group 0 or group 8 is not involved in this because group 0 elements are noble gases. They are stable, so they are not required to form any bonds with any elements. Alright, so we have group 1, 2, 3, 5, 6, 7. Okay, so then how are these group numbers related to valency? Very easy. So group 1 has valency 1, group 2, valency 2, group 3, valency 3, group 5, it's not 5, but it will be 3, group 6 will be 2, and group 7 is 1. Okay, so this is how we relate group numbers to valencies. Alright, so now we are ready to write chemical formula involving group number. Okay, let's have this example. Let's say I have magnesium chloride. Magnesium chloride. So, how do I write the chemical formula of magnesium chloride? Okay, I'm going to show you the common mistake that students make, and then after that we're going to do correction together. Okay, so magnesium, students know that magnesium, when they flip the periodic table, they know that it belongs to group 2. Okay, so magnesium, they're going to write down Mg. And then watch this. Usually what student will do is that they know that magnesium comes from group 2, so it will carry a 2 plus charge. Okay. And then chlorine or chloride comes from group 7. Okay. So group 7 has valency 1. And students know that it's valency 1, then they will write 1 minus. Okay, watch this. This is what usually students will do, which is absolutely wrong. Okay, I'm going to touch on the common mistake. Okay, so they know that they have to rewrite the symbols of the elements. Then what they do is they will crisscross. They will crisscross the charges, and then they will end up having this. Okay, then their final formula, they will write it as MgCl2 plus. Okay, MgCl2 plus. This is absolutely wrong. Okay, there will be a big fat cross there. And it's not just 1, 2, or 3 students who do this. Many students will do this, and it's not just for 1 year. It will occur year after year. Okay, so this is a common mistake. This is wrong. Okay, so what is the correct way to write chemical formula? Okay, I'm going to erase this. Okay, so that is why on my mind map I don't include charges. I only wrote down the valencies, okay, because I don't want to get carried away with the charges. Okay, so magnesium belongs to group 2, so it has valency 2. Okay, just write down the 2 there. Leave it like that. It's okay, leave it like that. Okay, it doesn't mean anything, but this is our working, so it's okay. Alright, then chlorine belongs to group 7. Group 7 has valency 1. Again, don't include the charges. Leave it like that. Just write the valencies. Okay? So next, students know that they have to rewrite the symbol and then crisscross the valencies. So I will have Mg1Cl2. Okay? And in chemistry, we do not write the 1, we will leave the 1 as blank. So our final chemical formula for magnesium chloride is MgCl2. Finish, that's all. Okay, and then my student will ask, like that only? Yeah, it's like that, it's like that. This is correct. Okay, this is correct. Alright, so there you have magnesium chloride, MgCl2. So recap, write down the symbol for each element, write down the valencies, crisscross the valencies, and that will be your final chemical formula. Can you all see the final? Okay. Alright, that's all. Halas. Habis. Finish. Okay, next, let's move on to type 2. Type 2 involves Roman numerals, okay, and what kind of elements carry Roman numerals in the name? Last week we have looked at transition metals. Okay, transition metals carry the Roman numerals in their name because transition metals are special metals. They have a variety of oxidation state. So what is so special about having variety of oxidation state? Okay, transition metals, they come in many different colors. Alright, so if let's say I have iron 2 ion, if it's a solution, it will be green in color. And if it's iron 3, it will be reddish brown in color. So transition metals, they are special because they carry variety of oxidation states. Alright, so these Roman numerals is referring to oxidation states, and that is why when you see fireworks, you see purple fireworks, red, orange, yellow, green. Okay, all this is due to the presence of transition metals, right? Subhanallah, it's just so amazing. Okay, and that is why when people dig gems under the ground, they see blue sapphire, they see red ruby. All these are due to the presence of transition metals. Okay, mashallah, yeah, beautiful. All right, so Roman numerals is also related to valency. Okay, so what kind of common Roman numerals that we see? Okay, common Roman numerals that we see will be, let's say, copper 1, Roman numeral 1. We also have copper 2. Okay, we have also seen iron 3. Okay, and then sometimes we see lead 4. Okay, so how are the Roman numerals related to valency? So if the Roman numeral is 1, valency will be 1. Roman numeral 2, valency 2. Roman numeral 3 will carry valency 3. Okay, if you hear somebody crying at the back, that is my toddler. Roman numeral 4 has valency 4. Okay, so now let's look at an example. Okay, so example, I have copper 1 oxide. Alright, copper 1 oxide. So how am I going to write this chemical formula of copper 1 oxide? So copper has a symbol of Cu. Okay, so Roman numeral is 1, so valency will be 1. Then oxide, remember last week oxide is just oxygen. So oxygen belongs to group 6. So if oxygen belongs to group 6, it carries a valency of 2. Okay? So write the symbol, write their valencies. Next, rewrite the symbol CuO, and we're going to crisscross their valencies. So 1 goes to here, 2 goes to here. So final formula of copper 1 oxide will be Cu2O. Alright, Cu2O. Okay? Understand? Easy. If you have any comments, if you have any question, okay, feel free to drop me a message, or you can simply comment in the comment box, but I can only reply you after this Facebook live streaming. Okay? Alright, so we're done with type 1, we're done with type 2. Next, we're going to look at type 3. So type 3 involves charges of polyatomic ions. Charges of polyatomic ions. Okay, again, I'm going to relate this to valency. Okay, what kind of polyatomic ions? Let's just recap what are the different types of polyatomic ions. We have ammonium NH4+, okay? Then we have hydroxide OH-. We have carbonate, nitrate first, let's do nitrate, NO3-, carbonate CO3, not enough space, let me just erase this. Okay, let's do it here. CO3, 2-, that's carbonate, and sulfate, SO4, 2-. So there are 5 polyatomic ions that we need to know, just these 5, alright? Ammonium, hydroxide, nitrate, carbonate, and sulfate. Okay, so looking at the charges, what are the charges that we see here? We see 1 plus charge, 1 minus charge, and 2 minus charge. Alright, so what kind of charges do we have? I'm going to write down here as 1 plus or 1 minus. 1 plus 1 minus can be combined together. And I also have 2 minus. Okay? So, if the polyatomic ion carries a charge of 1 plus or 1 minus, the valency will be 1. If the polyatomic ion carries a charge of 2 minus, it will have valency of 2. Okay? So 1 plus comes from ammonium ion, 1 minus comes from hydroxide and nitrate, 2 minus comes from carbonate and sulfate. So this is how we relate the charges to valency. Okay? Easy? Alright, so now we are going to write the chemical formula of a compound. Let's have this example. Let's have, let me see. Let's have ammonium sulfate. Ammonium sulfate. Ammonium sulfate. Okay, ammonium sulfate. So I'm going to write ammonium NH4. Okay, the 4 has to be written down because this 4 belongs to the hydrogen. It means that there are 4 hydrogen. So we must write down the 4. Okay, then ammonium ion has a charge of 1 plus. So what is the valency? The valency is 1. Sulfate is SO4. I'm going to write SO4. It carries a charge of 2 minus, so it has a valency 2. Okay, so now we are going to rewrite the symbol NH4 SO4. Okay, and we're going to crisscross the valencies. Okay, now when I crisscross the valency, I need to bring down the 2. Okay, but there's already a 4 over there. So how? I cannot just write a 2 there, then it becomes H42. Okay, so what I need to do is to write a bracket and bring down my 2. And you know that 1 we do not need to write the 1. Okay, so that is the final formula of ammonium sulfate, NH42SO4. Okay, so there you have it, the 3 types of writing chemical formula. Okay, 3 ways to write chemical formula. So recap, in writing chemical formula, you need the valency. And how do you relate valency? You can relate valency to group number or Roman numerals of transition metals or to the charges of polyatomic ions. Okay, and these three can be interlinked. Okay, so you just have to stick to the rules: group number, valency, Roman numerals, valency, charges, valency, and inshallah you are good to go. You will master writing chemical formula. Alright, so like what I shared yesterday during the math Facebook live streaming, in order for us to master a technique or a strategy, there are 3 easy steps that we can do. Number 1, we follow the example closely, like what I have showed you. These are examples. Make sure you know these 3 examples very well. Okay, and then number 2, go and practice more questions until you are confident. Okay, and then step number 3 is to teach someone. Alright, and then once you have completed these 3 steps, and then you will know that you have mastered a strategy or a technique that you are learning. Okay? Alright, so for those of you who wants to register for a free trial lesson, okay, we still have, okay, in Punggol, most of our classes are fully booked, right, except for our Saturday class. Other classes are already almost fully booked, alright? But we still have classes available over at Icon at Changi as well as Jurong East. But for Jurong East, we only offer PSLE Math as well as GCE O-Level Math. Alright, so if you want to sign up for GCE O-Level Chemistry free trial lesson, we have here in Punggol on every Saturday. And we also have over at Icon at Changi on every Saturday and Sunday. Simply go to bit.ly/YMS2018 registration. So that's all from me. Inshallah, I'll see you next week, same time, 8 p.m. And I will share with you another chemistry concept, inshallah. So I'm Ida Murni Jamari once again from YMS EduTech Learning Hub. Hurry to success. Assalamualaikum warahmatullahi wabarakatuh.